Alright, moving on with part F of the review. This is what I call normal limits, where you're not looking at a graph. Number 22, x approaching 8. The first step with every limit is simply to plug in whatever the value of x is that we are approaching, and that actually does give us the correct answer for number 22. Fraction exponents, I prefer to do this as 8 to the 1/3 and then square that, minus 8 plus 3. 8 to the 1/3, that's the cube root of 8, which is 2. 2 squared is 4, minus 8 plus 3 is negative 1. So that's all you had to do on 22, just plug it in. 23, if you plug in 5 squared minus 25 is 0. 5 squared, 25 minus 15 minus 10 is also 0. 0 to 0 means we need to cancel something. So in this case, we're going to cancel by factoring. So my top, x plus 5, x minus 5. My bottom, this is a pretty straightforward factoring, x plus 2, x minus 5. And then I can cancel the x minus 5s. And once you cancel, you revisit the limit. And when I plug in 5, I get 5 plus 5 over 5 plus 2, which is 10 over 7. And we'll leave it at that. Let's see, 24. They've got to start getting more difficult at some point. Here, this one's a little bit tougher. If you plug in 3, 2 times 3 cubed is 54. Minus 54 is 0. 3 squared minus 9 is also 0. So again, we want to try to factor and cancel. And here we will factor a 2 out of the numerator, leaving you x cubed minus 27. The bottom is a difference of squares, x plus 3, x minus 3. And then x cubed minus 27 is a difference of cubes, because 27 is 3 cubed, so that's going to factor as x minus 3, x squared plus 3x plus 9. We've talked quite a bit about factoring a sum and difference of cubes, so you should be able to find more details on that in your notes if you are having questions about factoring cubes. Once everything's factored, we'll cancel x minus 3's, and the instant you cancel, you revisit the limit, and we get, for an answer, 2 times, don't forget that 2's hanging out there, people may lose it, 2 times 3 squared plus 3 times 3 plus 9 all over 3 plus 3, which is 6. That's 2 times 27, which is 54, all over 6, which reduces to 9. Let's see, number 25. X is approaching 2, even though it is from the left side, that is a left-sided limit, we still will just plug in 2. 2 minus 5 is negative 3. 2 minus 2 is 0. And if you have a number divided by 0 in limit land, that means that we are looking at a situation where we have a vertical asymptote at that x value. So this function has a vertical asymptote at x equals 2, and we are concerned about the left side only. And the left side of a vertical asymptote will either be going up towards infinity or down towards negative infinity. And to determine whether we are going up or down is we will determine whether this fraction is positive or negative just to the left of 2. And we do that by testing something right up against it. So I'm going to plug in like 1.9 in my head. Or actually, I'll just write it down here. 1.9 minus 5 over 1.9 minus 2. That's a negative divided by a negative. If you divide two negatives, you do get a positive answer. Therefore, this thing is going towards positive infinity, which means we are looking at a situation like this on the left side of the asymptote. Moving on to number 26. X approaches 1. Well, if I plug in 1 here, 1 squared plus 3 is 4. 1 minus 1 is 0. So again, we have a vertical asymptote situation. So we have a vertical asymptote. So at 1, we have a vertical asymptote. Notice this side, I'm not asking about the left or the right, which means we need to look at both sides. And so we have to test both sides. So my left side, I'm going to test with like x equals 0.9. And if you plug in 0.9, 0.9 squared plus 3 over 0.9 minus 1 is going to be a positive over a negative. That's less than 0. So my left side is going to negative infinity, which means on the left side of 1, we're going down forever. If I test the right side, I'm going to plug in something like 1.9. And if I do that, 1.9, not 1.9, how about 1.1? 1.1 squared plus 3 over 1.1 minus 1. That gives you a positive over a positive, which is positive, which means the left or the right side is actually going up. And since the left and right sides are going to different places, the answer is does not exist. Left and right are different, so the overall limit does not exist. Number 27, x is approaching infinity. Pay attention to what x is doing. Don't just automatically assume you need to factor or something like that. X is approaching infinity. This is a nice polynomial or rational function. So I'm simply going to compare degrees on top and bottom. They are equal, so we will divide the coefficients, and we will have 1 divided by 2 for the answer. That's the easy way. If the degrees are equal, that's what we call Betsy. If the bottom equals the top, we will divide coefficients, and so we will divide them to get an answer of 1/2. If you forget those rules, the other option is you could take your function, look in the denominator, find the highest power of x in the bottom, and divide every single term by that high power of x. And so my high power of x in the bottom is x squared. So if I divide every single one of these terms by x squared, and that is a legit operation, you can do that. You can do that. And then reduce each of those fractions. X squared over x squared is 1. 5x over x squared will reduce to 5 over x. 1 over x squared is already reduced. 2x squared over x squared, the x squareds cancel. And 8 over x squared does not reduce at all. And then when you evaluate it as x goes to infinity, any number divided by infinity, all of these numbers over x's will approach 0, approaches 0, approaches 0, approaches 0, and so we're left with 1 plus 0 minus 0 over 2 minus 0, and you still get 1/2. Now that way obviously takes a lot longer, but it is safer because that one approach works for all 3 of the degree rules. And so if you want to do that, have at it. Let's see, 28. Again, x is approaching infinity. When there are radicals in the problem, I strongly recommend doing the divide by the high power of x. So I'm going to give me a little bit of room to do that because my numerator is going to get kind of crowded. There we go. So now I have some room to work in the numerator. So I'm looking in the bottom. My highest power of x in the denominator is x to the first. And so I'm going to divide every single term by x to the first, divide by x to the first, divide by x to the first. But under the radical, because I want what I divide by to resemble the term, instead of an x to the first, I'm going to use the square root of x squared. The square root of x squared. And then I'll reduce each of those. And so x divided by x is 1 over here. In the denominator, x divided by x is again 1. 7 divided by x is 7 over x. And for the radical, we have the square root of stuff, and so I'm going to combine it into one big square root, and then I need to do x squared divided by x squared, and I need to do x divided by x squared. So I'm going to do both of those. X squared over x squared is 1. X divided by x squared is 1 over x. And now I can approach infinity. And when I do that, any number over infinity turns into a 0. So that's 1 plus 0 minus 1. Root 1 plus 0 minus 1 over 1 plus 7 over infinity is also 0. And I get root 1 minus 1, which is 0, divided by 1, which is 0. So there's our answer to this one. All right, number 29. Again, x is approaching infinity. And here, my top degree is bigger than the bottom. So if you're bigger on top, that is what we call undefined. However, we can specify the undefined as the function going to infinity or negative infinity. As this function works out to the left, it will either be going up or down. And so to determine the sign, I'm simply going to compare my high power terms. So I'm going to look at those two terms. Those are my high power terms. And if I plug in a huge negative number, so if I plug in a huge negative, and I'll say if x is a huge negative, then what I have is negative x cubed, and if I plug a big negative number into that, that will end up being positive over a negative x squared. Well, if you square anything, it's going to be positive, but the negative in front will make that negative. So we have a positive divided by negative, which means this thing is actually going towards negative infinity. This function is going down forever. You just have to determine the sign of the fraction, and for these infinite limit ones, the highest power of x, that term is what's determining whether we are going to be going up or down. So moving on to 30. If I plug in 9, I will get 0 over 0. I see a radical in this term, so I'm going to use conjugates. So that'd be root x plus 3 on top and bottom. And when I clean that up, the top we will not simplify. Leave that as x minus 9 times the square root of x plus 3. When we multiply the conjugates, remember you only have to do the first times the first and the last times the last. You don't have to do the full foiling because they will all cancel out. So root stuff times root stuff is just the stuff. Negative 3 times positive 3 is negative 9. And that's really nice because I have an x minus 9 on top. Cancel the x minus 9s. If you want to put a 1 placeholder in the denominator, you can. It's not really necessary. And then we will finish by plugging 9 in for x. And we get the square root of 9 plus 3 divided by 1, which cleans up to 6. All right, 31. X is approaching 5. If I plug in 5, I get 6 divided by 5 minus 5 is 0 squared, which is yet again, I seem to have a lot of these, yet again another asymptote situation. At 5, I'm going to have a vertical asymptote, and I do need to look at both sides of 5. I need to know if the left side's going up or down, and if the right side is going up or down. And so I'm going to test the left side by plugging in something like 4.9. And if I do that, I get 4.9 plus 1, which will be positive, 4.9 minus 5. But I square that, and that's going to give me 2 positives. It's greater than 0. That means my left side is going up. My left side's way up there. My right side, I'm going to test with 5.1. And if I do that, 5.1 plus 1 over 5.1 minus 5 squared. And that will also give me 2 positives, which means my right side is also going up. Because left and right are going in the same direction, they are both going to infinity. That means that the overall limit is approaching infinity. So therefore, the answer is infinity. All right, moving on, 32. Again, if I plug in negative 2, always plug in your value first. You will get 0 divided by 0, which means we need to work towards canceling something. And if I ever have fractions inside a fraction, which is what I have here, I'm going to look at the 2 smaller fractions, 1/2 and 1 over x, and I'll find the common denominator, which in this case is 2x. And then I will take that 2x, and I'm going to distribute it only through the 2 little fractions. I am not going to distribute a 2x through the denominator. I'm going to leave it as the quantity x squared minus 4 times 2x. Here, if I distribute that 2x times 1/2 would be 2x over 2. 1 over x times 2x is 2x over x. And the whole reason I'm distributing is that allows these 2 fractions to reduce so that they are not fractions anymore. Well, they're fractions over 1, but picky details. So I have x minus 2 on top. On bottom, I can factor the x squared minus 4 to x plus 2x minus 2. And then I have a 2x. And if I cancel those x minus 2's, there's nothing left in the numerator. So now I'll put a placeholder of 1. And now I will plug in negative 2 for all the remaining x's. And I think I have messed up somewhere. What did I do wrong? I did mess up. Whoops. Okay, so I'm going to have to undo. I accidentally changed my plus right here to a minus. The reason I knew I had messed up is because if I plugged in negative 2, I would still have a 0 in the bottom. That should not happen after you cancel. So I'm going to go back and undo a bunch of stuff. Actually, I'll leave all of that. do need to change this minus to a plus. Now when I cancel, I'll cancel the x plus 2's. Give me my one placeholder. And now I'll plug in negative 2. So I have 1 over negative 2 minus 2 is negative 4. 2 times negative 2 is negative 4, which is 1 over 16. There we go. Whoops. Whoops. Let's see, number 33, x is approaching infinity. This one, nice rational function, no square roots. This is Bobo. When you're bigger on bottom, the answer is 0. And so bottom degree is bigger, the answer is 0. If you want to, you could divide by the high power of x on top and bottom, and it would still give you the same answer. There. See, told you. Divide by x squared, and you end up with a whole bunch of zeros, and 0 divided by 1 is 0. All right, so moving on. 34. This one's probably going to be the most difficult one. How many more problems are there? I think that's it. Yeah, okay. So 34. X is approaching infinity, which is when I want to do the degree on top and bottom, or divide by the high power of x in the denominator. The problem with this one is there is no denominator with variables. The current denominator is 1, and that's a problem. So we're going to force variables into the denominator by multiplying the top and the bottom by the conjugate. So I'm going to multiply by root 2x plus root 4x squared minus x over 2x plus root 4x squared minus x, which cleans up 2. And again, when you multiply the conjugates, you only have to do the first times the first and the last times the last, which is going to give me 2x times 2x, 4x squared, minus, and root times root is 4x squared minus x, but make sure you remember to group that in parentheses because you are subtracting the product of that whole thing. The bottom, we'll just leave alone, 2x plus all this stuff. 4x squared minus x. And in the numerator, if I distribute that negative now, we'll have 4x squared minus 4x squared plus an x. The 4x squareds cancel. They subtract out. Leave me with only x over all of this stuff. And finally, I have variables in the top and the bottom, which means I can look at my denominator and find the high power of x. This is very similar to the last problem. It is x to the first in the bottom, and for the square root to resemble what I'm dividing by, I'm going to divide by, or resemble that radical, I'm going to divide by the root of x squared. I have root x on top, and that reduces to 1 over 2x over x is 2 plus, and this square root right here, we'll do the x over the x squared as well as the 4x squared over the x squared. And that's going to give me the square root of 4x squared over x squared is 4, x over x squared is 1 over x. And now there's only 1x left for the infinite limit, which means that 1 over x is going to approach 0, giving me a final answer of 1 over 2 plus the square root of 4, which is 1/4. So there's our answer to 34. Oh, too far. Number 35. Okay, another one, x is approaching infinity. This time it's negative infinity, but x is approaching infinity. And all I need is x's in the top and bottom, which I have. Do not use conjugates here because I already have variables in the numerator and denominator. I'm going to divide everything by the high power of x. I'm going to give myself a little bit more room to do this. There we go. Okay, so in the denominator, my highest power of x is x to the first. So I'm going to divide every term by x to the first. But remember that under the square root, we want to divide by the square root of x squared. And then the last thing you have to remember about this one is if x is approaching negative infinity, that means that x must be negative. We want things to be negative, and we want to preserve that negative for the square root of x squared. So it's not x equals the square root of x squared, because square root of x squared will be positive. It's the negative square root of x squared. So I'm going to put a negative down here to preserve that negative infinity behavior. And when I reduce these, 3x over x is 3, 1 over x is 1 over x. over x is 1. These two negatives minus a negative, that creates a positive. And then I have the big square root, and just like all the others, we will divide each of these, 16x squared over x squared and 7x squared over x squared. So that gives me 16 and 7x squared. 7 over x squared is 7 over x squared, doesn't reduce. And finally, I will take my limit, and I want to know what's happening as we go towards infinity. And both of these numbers over infinity will approach 0. Giving me a final answer of 3 plus 0 over 1 plus the square root of 16, which cleans up to 3/5, and there's our answer. So just remember that if x is going to negative infinity and you're using that square root dilly hopper, you have to use negative root x squared. 36 looks weird because x is approaching 5 from the right, but with every limit, you always just plug in your number. And even though it is coming from the right, when I plug in 5 for x, I get 25 minus 16, which is 9, and 5 plus 5 is 10, and that's your answer. Nothing tricky about that one. Please do not plug in 5.1. We just need to plug in 5, and we don't get any problems with it. So there we go. Finally, all of those. Jeez.